It will consist of a presentation of around 40 to 45 minutes, followed by a question and answer session for around 15 minutes. During the presentation, we ask that people keep their microphones on mute. However, you can type questions via the chat function at any time. If you're not familiar with Teams and how to do that, you just click on and open the little speech bubble at the top of your screen, and you can type into the chat function. At the Q&A session time, you'll be able to continue to type questions into the chat, or you can raise your hand using the reactions or the hand button also at the top of the screen, and we'll facilitate that and ask you to come in with your question. Please, if you are asking a question, please do remember to mute your microphone again afterwards. Following today's session, we will be uploading the webinar onto our website. So anyone who's missed it, or if you wanted to go back and revisit, you'll be able to do that. Importantly, we do have some acknowledgements for our funding bodies and research partners today. The extreme climate tools that Debbie's going to be stepping us through have been developed as part of the Forewarned is Forearmed project. The 5-year project is supported by funding from the Australian Government Department of Agriculture, Water and the Environment as part of its Rural R&D for Profit program in partnership with 14 project partners, including Sugar Research Australia. The project is managed by Meat and Livestock Australia, and SRA gratefully acknowledges co-funding received from the Queensland Department of Agriculture and Fisheries for this research activity. I'd now like to introduce Debbie Hudson. Debbie is a principal research scientist with the Bureau of Meteorology, working in multi-week and seasonal predictions and applications. A key component of Debbie's work is leading research and development projects and interacting with stakeholders. Debbie has a PhD in climatology and has been at the Bureau for nearly 20 years. Debbie, thanks so much for joining us, and over to you.
Thanks very much, Kathy. It's really good to be here. And as Kathy said, I'm going to be presenting to you about the Forewarned is Forearmed project, which looked to develop new outlooks focused on the agriculture sector. But before I do that, I'm going to give you a little bit of a background into how seasonal outlooks are actually made and what Access S is. Then I'll introduce the project to you and then talk a bit about some of the new forecasts that are available and what's coming next. So first of all, how do we actually make seasonal forecasts? So for seasonal forecasts, we use the same kind of models that give you your weather forecasts, and they're what we call dynamical models because they're based on the equations of physics. So they're based on things that, you know, the way we know that, say, heat and moisture are transferred within the atmosphere or between the atmosphere and the land surface. And so really it's like a computer simulation of the real world. And what happens is that the globe is broken up into grid boxes, and in a seasonal forecast model, the grid box typically has a resolution of about 60 kilometers by 60 kilometers. But then we also model what goes what's happening up into the atmosphere. So we have layers that go up into the atmosphere. And for seasonal prediction, having an ocean model is very important. So we also model what's going on in the ocean. Now, the Bureau's seasonal prediction system is what we call Access S. And so this animation that you can see here is actually the output from one forecast run with Access S. And it's showing how it's simulating the weather day by day, just like the models that produce the weather forecast. And here you can see the lines are pressure and the shaded blue areas is rainfall. And you can see features like tropical lows, that there'll be a tropical cyclone that's going to come along here soon. Yep, there it comes. So the model is simulating what's going on in the atmosphere every single day. But there's uncertainty in how the weather will evolve. And because of that, we don't just run one of those, we actually run 100. And so So we're running, 100 plausible scenarios or outcomes, and that's actually what we use to provide the probabilities that you see when you look at the seasonal outlooks. So, for example, if 80 of those 100 outlooks predict above average rainfall for a given season in your area, then it's basically saying 80 of those are suggesting that it's going to be wetter than average. But remember that 20 of them also said it would be drier. So I think that the key thing with seasonal forecasting is that, although users or everybody wants to know exactly what's going to happen, people want to know, is it going to be dry or is it going to be wet? But really, it's more about probability and risk and shifts in the odds. So, how are the odds stacking in one direction or the other? And so it's taking this full information rather than using a single outcome. So just to give you a little bit of background, what a forecast system is. So Access-S, as I said, is the Bureau's seasonal forecast system. And at the core of it is a model. And it's what we call a coupled model, which means that it has got an atmospheric model coupled to an ocean model. But there's also a land surface model and a sea ice model. And as I said before, it's essentially a computer simulation about what is happening in the atmosphere, ocean, and land. But we actually need more than just the model. When we run a forecast, we actually need to be able to start the forecast with our best estimate of what the current state of the atmosphere, ocean, and land is now. And so we get all the latest observations that we can from like ships and satellites and ground stations to get a picture of what the land and the atmosphere is. And this process of getting the observations and putting them into the model for the start of the forecast is what we call data assimilation. And that process is actually almost as complicated as the model itself. And so then once we have that initial starting point, the model can then freely evolve, like you saw in that animation, to create the forecast. But as I showed previously, we don't just run one, we run multiple, because we need to take into account that there's uncertainties in the way that the weather can evolve. And then the other thing in seasonal prediction is we run a set of forecasts for a period retrospectively in the past, which we call a hindcast. And usually that's about a 30-year period. And the reason we do that is we use that to look at how good the system is, what is the skill of the system. And we also use it to calibrate the forecast that we issue in real time. And of course, we have to process the output from the model to produce the kind of forecast that you see on our web pages for forecasts of El Nino or Australian climate. So really, Access-S is more than just a model. Now, we've just had a major upgrade to our seasonal prediction system from Access-S version 1 to version 2. And the main changes that we made in the system were actually in this data assimilation part, so getting the starting conditions for the model. And changing the data assimilation can actually have a very big impact on the forecast. So Access-S version 1, so the development of our seasonal prediction system is a collaboration with the UK Meteorological Office, and we use their model. And in version 1, we also used their ocean starting conditions. We ran our retrospective forecast over a 23-year period, and Access-S1 was running since the middle of 2018. But now our Access version 2 went live in October last year, and Access-S supports several services. The one you're probably most familiar with is obviously our seasonal climate outlook, but we also provide outlooks for the Pacific Islands and actually global outlooks. We also the output from our Access-S also feeds into a water balance model and produces seasonal forecasts of soil moisture and runoff. And this is a relatively new product at the Bureau. So maybe you want to go and explore that and look at what some of the outlooks for soil moisture and runoff and also evapotranspiration. And then we also serve data to external customers. So as I said before, the main difference between S1 and S2 is that in S2, we actually do our own data assimilation. We produce our own initial states. That has an implication that we can actually do it. We can actually create the forecasts faster, more readily, which means that they actually more accurate, more timely. It means we have less reliance on the Met Office. The model is pretty much the same in Access S2, but what we've also done is we've done a larger test period over the past, and that's actually really valuable because it helps us to get more robust estimates of the system's performance, and it's also better for our calibration. So I'm just going to show you two things about the improvement. So in Access S2, it looks like we've actually got better ocean initial states than we had in Access S1, and that actually improves our forecasts of El Nino and La Nina, especially during autumn. And so what this graph here shows is correlation skills. So on the y-axis is correlation, so higher values are better. And it's showing the correlation for Nino 3 sea surface temperature anomalies, which is an indicator of El Nino and La Nina. And then on the x-axis is the progression of the forecast in months. So as you go out in the forecast, the skill or the correlation decreases. But you'll see that in Access S2, that skill is decreasing less rapidly. So the skill is better in Access S2 compared to Access S1. And this is really good for this time of year because forecasts that start around now and in May, in autumn, it's a really challenging time of year for forecasts, and all international models experience difficulty predicting ENSO at this time of year. So that's a really pleasing result. The other thing that we've improved is the starting conditions for soil moisture in the forecasts in Access S2, and we've made that more realistic. And that's actually made a big difference for our accuracy of our maximum temperature forecasts. So what these maps show is this is forecast starting in May, and the skill that you get for May for Access S1, Access S2, and the difference. And so in these two, the warmer colors indicate better skill. And in this one is showing the difference. So the Access S2 skill minus S1 skill. So red is better. So you can see that there's a significant improvement in the skill over Eastern and Australia, well, over most of Australia, but particularly over Eastern regions. Okay, so now to come to, so that was a bit of background, now to come to the actual project Forewarned is Forearmed. So Forewarned is Forearmed has been a large agriculture funded project, as Kathy mentioned. And basically the aim of the project was to provide new multi-week and seasonal forecasts. And we wanted to answer questions like, what is the chance of having an extremely wet season this spring, maybe a decile 9 or 10 season? Or what is the chance of having a heat wave in the week after next? So getting at more than just what is the chance you're going to have above or below median conditions. And so in this project, we've got multiple research partners, you can see here, who are experts in different agriculture sectors. And we also have funding and involvement from several RDCs, including Sugar Research Australia. And a key aspect of the project has been users. They've played a really critical role, and we've had reference groups for the key sectors that have funded the project, including a sugar reference group. And our sugar reference group was run by the University of Southern Queensland and DAFQ. So one of the things that I think makes the project exciting is that it actually encompasses an end-to-end approach, and I think that really has increased its effectiveness. So it's included underpinning science, forecast development and delivery, engagement with users, how to interface forecasts to industry decisions, and ultimately the delivery and extension of a new service. And of course, we've had throughout the project, what's been really good is we've had interactions and feedbacks between all of these components. So as I mentioned before, our project partners have been the ones leading this interfacing to industry decisions and the development of risk management strategy. So in the case of sugar, that's been USQ and DAFQ. So when we develop new Outlook products, it's pretty much based on a foundation. And that foundation I like to think of is basically understanding the user needs and also sort of the underpinning science. So at the start of the project, we had a series of workshops and with each of the sectors involved in the project. And those workshops were aimed at understanding, you know, what are the main weather and climate risks? What are your main pain points? What are your key decisions? How might a forecast help you? What action might you take if you had a forecast? And, you know, how far in advance do you need to know? And this type of information and feedback has been ongoing through the project. And you'll hear a little bit more about this from a sugar production perspective at the webinar on Friday with Robert Quirk and Tom Bowditch. Another big component is the underpinning science. I'm just going to give you one example. So this is one piece of work that's come out of the project. And basically it's pretty amazing, because what goes on way up in the stratosphere above Antarctica can actually have an influence on the risk of us having extreme weather and climate over Australia. Basically, when the very strong winds above Antarctica in the stratosphere weaken and the air there warms, we have a much higher risk of having hot and dry conditions over Eastern Australia and severe fire danger conditions. And the thing with this research is that all of the science that we did there actually eventuated in 2019 when the air above Antarctica did warm unusually. And we did end up having very hot and dry conditions and catastrophic fire danger in spring of 2019. And because we'd done this underpinning science, it actually gave us confidence in what the forecasts were saying. It gave us an understanding of what was going on, and then that impacts how we can communicate with users. So it's very important for us to be able to understand what's going on in the forecast system and how the climate variability works. Okay, so now moving on to the development of the forecast products. So what we did in the project is the aim was to develop a whole range of new forecast products looking at cold, heat, and rainfall, multi-week to seasonal forecasts. And we made them available on a research web server. You can just see a snapshot here for trial and feedback. And these forecasts were updated in real time every single day. And you can see on the left-hand side here is a list of all the products that we developed. So it was a bit of a brainstorming approach. And so our users were pretty much involved in our brainstorming approach. They could see as we started adding new products. And the aim was then that we got feedback from the users. Because the project has several agriculture sectors involved, the products weren't tailored specifically to individual sectors in terms of, like, you know, an index, particular index. So they were pretty generic. And so we gathered feedback from our industry reference groups on the look and feel, the interpretability, how useful the products might be. And you'll hear a bit from Robert and Tom on Friday how they've used the forecasts. So really, the users have played a critical role in the development of our forecast products right from the beginning, from the start of the project. And so from this brainstorming approach, the ultimate aim was to select 5 of those products, which would then appear on the Bureau's website. And we chose those 5 in consultation with our user groups and with the RDCs. So, and as I said, we gathered feedback from the reference groups. The project also has had a community of practice. We have a community of practice group run by the Birch Cropping Group, which has monthly sessions, and we've collated all the feedback. So when we developed the products, so some of the products were map-based, and that's fine, but some of the products actually were specific to a location. So you would, you know, be able to click on a location and have a product. But for our research testing, we tested these new products on about 560 locations across Australia. And for sugar, you can see the sugar stations that we had 80 stations. So these were stations that for which we produced forecasts that the users in our reference groups could actually go and look at forecasts for those locations. Okay, so now I'm going to talk a little bit about the actual 5 products that have ended up being selected. The first 2 products are already operational. The first product is maps showing the chance of it actually being very hot or very cold or very dry and very wet. And by very, we mean the top 20% being amongst the top 20% of, say, wettest seasons, or being in the top in the bottom 20% of driest seasons, for example. And I'll show you a little bit more about that. The other product is these bars, and this is an our location specific product. So I'm showing, for example, here Mackay, and basically it's separating out into deciles. So we have at the one side decile 1 and 2, so your driest 20%, and at the right hand side decile 9 and 10, so your wettest 20%, and then the 20% categories in between. And so the usual chance of having any particular outcome in those is 20% by design. And then you look and see how the forecast shifts those odds. And I'll explain that a little bit more now. But the one thing I wanted to show you in this slide is on the left-hand side is what the product looks like in our experimental website, R&D website. Now, because we created a whole lot of products, we didn't put a huge amount of effort into producing, beautiful displays, snazzy graphics, features. But once these 5 products have been selected, then we've had a second round of feedback with feedback opportunities for what that product's actually going to look like. And that's shown on the right-hand side when it's actually displayed on the Bureau's website, where we take, more attention to, the colors that we've used, the text that's used. Okay, so the 2 extreme climate outlook products that are available now. First of all, so where does it appear on the website? So hopefully you're familiar with the Climate Outlook's website, and normally you would go, there's rainfall and temperature. So I'm just going to show here for rainfall, but the same exists for temperature. And normally you would click on your sort of chance of above median. For these products, there's another tab called chance of extremes. And because we're looking at rainfall, you can click on the unusually wet or the unusually dry. And it comes up with a map, and it's available for the same time periods that are available for the chance of above median. And then you can click on the map and it will come up with a location-based products. A lot of users don't know this, but you don't have to click on the map. You can actually also search for your location. So if you click on that more magnifying glass and you enter in your station, your location, then it will come up every time with your location there. And maybe later we've got this demo that shows interactively what I've just shown you here about navigating the products. So now let's just look a little bit more detail at what the product is. So this is I'm showing an example for rainfall, but the same holds true if you look at maximum or minimum temperature. And so this is showing what is the chance of it being unusually high rainfall. And this example is the forecast for November to January, November last year to January this year. So that 3-month season. And by unusually wet, as I've said before, it's what is the chance it's going to be amongst the wettest 20% of seasons that you've had for that time of year. And so because we're talking about the wettest 20% of the seasons, usually that your usual risk is 20%. And so where it's shaded here is showing where the odds are stacked to it being stacked towards to it being more an elevated risk. So here, these green areas, so where it says, say, for example, a 40% chance of it occurring, that's twice the usual risk. So it's an elevated chance. So, your odds are now stacked towards you having an increased chance of a wet, a high rainfall season. And then if you were to click on the map or search for your location, you would come up with these bars. So again, this bar, there's the usual chance, which is the 20% line. But now this bar shows more than this map, because this map here is just showing the unusually wet conditions. So that map is really only showing you this decile 9 and 10. What's the chance you would decile 9 and 10? These bars are showing you the whole distribution. So it's showing you that, so for this location, for example, the 20% of driest seasons have rainfall less than 123 millimeters. The 20% of wettest seasons have rainfall greater than 242 millimeters. And so usually there's a 20% chance of you having rainfall in any one of those categories. And then we run our 100 forecasts and say, well, what is the forecast indicating? What are those 100 forecasts saying that where the rainfall will fall? And you can see that's what these bars are showing. So it's showing that those 100 forecasts are stacked towards a wetter season. And so if we look at the dry is saying there's a 7% chance of dry. So that's a reduced chance compared to what we'd normally have. So it's showing, and the wetter season is showing an increased chance, so nearly double the usual risk. Then there's some other information up here as well. So it tells you what your historical median is. So in this situation, it's 186. So that's like in the middle of this distribution. And then it's telling you in words here what you can actually read off there. So the chance of unusually dry, so less than 124 millimeters, is 7%. The chance of above median, it tells you, and the chance of unusually wet. And then the stars here indicate the accuracy. So 3 colored in stars mean good accuracy, whereas 1 colored in star means accuracy is probably quite poor. The same that you get with your probability above median maps, you can also click on the website to find out the accuracy. You can actually also, so those bars told you what, say, your threshold was for your wettest seasons or your driest seasons, but you can actually also have a look and see in a map what that means. So this is showing your 20th percentile rainfall. So rainfall less than these amounts would mean that you had a very dry season. And then there's information that explains more about these new products. So we've had some early feedback from producers and from collaborators, and some of them are just put here. So the tools are really valuable in planning our work program. So a lot of the comments have come that managing a slightly above or below average season is easy, but really what we want to know is, are you going to have a very wet or very dry or very warm or cold season? And being forewarned means that you can make decisions based on what the products are forecasting. And this comment here about, working with the Bureau on these products highlights the value of a co-design approach. And that value means that, from Bureau perspective, we get insight into the kinds of decisions that you make, the kinds of forecasts that you need, and also how we can actually better communicate those forecasts. So now I'm going to just show you what the current outlook is, but show it with these new extreme products. So this is the April to June outlook for this year. And this outlook is showing what is the chance of it being unusually wet or dry. And so the one on the left is showing what is the chance of it being unusually wet. So what is the chance you're going to have a rainfall season that falls in the top 20% of the historical range. And the green, light green here, for parts here of Eastern Australia are showing, 30 to 60% chance of unusually wet. And so a 30 to 60% chance means 1.5 to 3 times increased risk compared to what you normally would have. And some of these areas here in the top end, in the far north, there's up to 80% chance. So the odds are stacked towards having a very wet season. If we look at this is now the opposite. What's the chance of it being unusually dry? So what's the chance of it being in the bottom 20% of your historical range? And you can see that for most of the map, it's this sort of like light gray color. And that means strongly reduced chance. So there's a reduced chance that you're going to have a very dry season. On the other thing to note, on these rainfall maps, there's this funny shape, gray shape. That's a mask, just masking out areas where there's very few observations. If we look at the outlook for April to June for maximum temperatures, so daytime temperatures, you can see that there's a strongly increased chance of having a very warm April to June in the top 20% over northern and eastern Australia, and there's low chance of having unusually cold conditions. For minimum temperatures, so nighttime temperatures, most of Australia is showing an increased chance of having really warm nighttime temperatures. Okay, so what's, I guess, next for the project? So we've switched to Access S2. So when we switched to our new operational model, that's when we also introduced the new products that I've just shown you. But then in June this year, we're going to be releasing the next 3 products on the website. So I'll just show you a little bit now about what those products are. And I'm showing you now these products as they look in our research website. So not what they're going to look like when they actually appear on the Bureau's website. When they actually appear on the Bureau's website, they'll probably look a lot, they'll look a lot better, they'll have better text. Anyway, so this product is what we call our weekly and monthly climagrams. And so it's a location-specific product for rainfall and temperature. At the top here, I'm showing an example for the weekly product. So it's essentially a time series. So it shows past weeks. So the solid line here shows so on the y-axis here is your maximum temperature. It shows the weekly maximum temperature for some past weeks. And then the dashed line with these boxes show the forecast. Now, what these boxes show is the range from those 100 forecasts that we ran. So you can see, how certain or uncertain the forecast is, how wide is the spread. And in the background in gray is actually the usual conditions for that time of year. So this middle gray line, if you can see here, is the median, the usual median. So in this forecast here for the week 1, this box is lying quite low down compared to what's usually expected. So it's putting the forecast in the context of what's usually expected. So it's a cooler forecast than you would normally have for that time of year. So that's just added information. You don't have to compare it to past conditions because you can actually just look and see what the actual temperature is that it's being forecast. Equally, there's also the monthly time series. So the solid line shows past months of observations, and then the bars show the forecast. Then this is another product which is available only for rainfall, and it's what we call our probability of exceedance curves. And again, it's a location-based product, and it's probably the most complicated product. And in some respects, we were quite surprised that it ended up getting selected. But I think that, it's a complex product, but it's quite valuable once it's understood how to use it. So really what it's showing here is on the x-axis is rainfall totals, and this is available for weeks, fortnights, months, and seasons. So this example here is for a forecast for the month of April coming up. So rainfall totals for the month of April. The black line, don't worry about the dashed lines, but the black line is the forecast. So you can pick a rainfall amount that you're interested in, say 200 mils of rain, and you go up and you then go across and you see it's got about a 25% chance of getting 200 millimeters of rainfall. And so you can select whatever threshold that you are interested in. The other use in this diagram is the light gray line, because the light gray line shows what usually happens for that time of year for that station. And so you can see if we look at the, say 200 mils, usually there's only like a 5% chance of getting 200 mils. So the fact that this black line is above it is showing that it's a much wetter forecast. Another way to look at it is that these curves all slope from the top left down to the bottom right, because essentially, you've got a greater chance of having smaller rainfall amounts. And then as you get to higher rainfall amounts, the chance of you having them decreases. So essentially, this product allows you to sort of select whatever rainfall amounts you're interested in and delve more deeply. So some users are not going to be interested in this kind of complex information, but there has definitely been interest from other users. And then the last product is what we've called the rainfall burst. And basically it's looking at the rainfall that might happen over 3 consecutive days. So trying to get at, might there be, instead of looking at like over a whole week or a whole fortnight where you don't know if the rain's fallen as drizzle over the whole week or whole fortnight, it's looking at more, what is the chance I'm going to actually have a burst of rainfall? And so what it is we've got different thresholds. So you can select a threshold. So say 50 millimeters of rainfall in 3 days, or 75 millimeters of rainfall in 3 days. And then it tells you the chance of actually getting that. And this is available only for the weeks and fortnights ahead. And this product in particular was very useful, had very favorable feedback from our northern groups, particularly the livestock industry. And one of the things they're really interested in is something like 50 mils in 3 days. So essentially, that is our portfolio of 5 operational products. 2 are already operational, and then these remaining 3 are going to become operational and visible on the Bureau's website in June. And as I said earlier, because we have several different agriculture sectors, as you can see, they're not tailored products. They don't have sort of tailored indices like growing degree days or whatever it might be. But that also means that these products are probably going to be useful for a whole range of sectors, not only agriculture, and also different use cases. So finally, the last point that I want to leave with you is I think that really the value of this project has been in like the co-design and the engagement. And I think that we really need to do more of this because it really does help with communication, with actually influencing the final utility and understandability of the products that we produce. And I've just got this little diagram here. So basically, no matter how accurate a weather forecast or climate outlook is, if it doesn't actually provide the information that you need, if it's not issued when you're making your critical decisions, if it's misinterpreted, and that often happens with probabilistic forecasts, which are challenging to interpret. And if it can't help you make a decision, then it doesn't actually have real value. So that's why we really do need to have partnerships to actually kind of unlock the value in these seasonal forecasts. And I really like this picture here. It shows, this is the sidewalk that was built, but clearly this is the sidewalk that the user wants. So the real value of engagement. So that's it from me, Kathy. I'm happy to take any questions. So I don't know if, hopefully you're all aware that we have, climate and water outlook videos. So the latest video was issued at the end of last month, and that will take you through more of the forecast for the upcoming season. And yeah, those maps that I showed you are all available on our Climate Outlooks website. Thanks.
Thank you, Debbie. Look, I have reached out to people via chat. Please don't be shy. If you have questions for Debbie, please either raise your hand using the chat or, feel free to type those questions in. Debbie, I have also shared the link via the chat to the video, so that people have easy access to that. I guess if I kick off with a question while we're waiting to see if any others come through from our guests on the call, we obviously have recently seen some extreme weather in southeast Queensland and northern New South Wales. I'm interested in whether you've received further feedback about the usefulness of the tools since that time. Certainly in slides you shared some of the feedback from some of those users, but has there been anything specifically in the context of the recent weather events?
Yes, I'd say that the feedback's mainly been on the forecast for the months and seasons ahead in terms of that. So quite consistently, our forecasts have actually been indicating wetter, much wetter than average months and seasons over the last few months. And obviously that's eventuated over large areas. And that's pretty much due to the fact that we've had this La Nina condition. And again, I think it's the feedback has been about, the insight into not just, probability of above median. Well, is it going to be just a little bit above median, or is it going to be a lot above the median? And so a lot of the feedback has been on, having more insight into what it might mean and how the odds might be shifted.
Look, that's certainly some of the feedback I've heard from a user, and without stealing the thunder of Friday's session, there will be a little bit of a salient lesson there in terms of, we were warned. And how the tools may be able to influence or support decision making, within the agricultural setting. I see that we've got a question come through, Debbie, from a person on the call. It's asking or indicating that there used to be a tool for predicting the date of the northern wet season.
Yep.
Is the 3-day burst tool a replacement for that?
No, it's not a replacement, it's an addition. So there's still that. What Michael's talking about is there's a forecast for the onset of the northern wet season. And that's basically saying after, when after September might we have had an accumulation of 50 millimeters of rainfall. And that was that was devised in conjunction mainly with livestock users, as in that's really when the pasture starts being available. And so that's saying, that actual product is saying, are we going to expect the wet season to happen earlier or later than we normally would? So say normally you would expect the wet season to start on the 1st of February. Are you expecting it earlier or later? So that's still available. The burst tool is more of a what might happen in coming weeks, and so it's saying, well, in the next few, and it's available the whole year round. So that start of the wet season is really just when might the wet season start. This burst product is looking at 3-day rainfall accumulations throughout the whole year. So it equally might be useful for southern producers in winter, an indication of bursts of rainfall, and of different amounts. So not only that 50 millimeters of rainfall. So it's an additional tool.
Thanks, Debbie. Look, some feedback also from Mick saying, thanks for a great presentation. He does ask whether there's a contact for support as end users start using the tools in their businesses.
Yeah, that's a really great question. So I would say that the best contact is, so the Bureau has got sector groups. We have an agriculture program, and I'll maybe look and get the actual website link and put it in the chat in a moment. And so the best is actually to make contact with our ag program staff, and then they will be able to either help you or be able to channel you to the right people who might be able to help you.
Just of one of those tips that you shared, Debbie, and when we caught up recently, you pointed it out to me, and I know you pointed it out again today, but as someone who was, I guess, noodling around in the tool, that search magnifying glass to actually really be able to hone in on your location is invaluable, and not immediately obvious to people, right?
Yeah, exactly. It really shouldn't be so hidden. But yeah, so you don't have to oh my gosh, where's my location? Can I click on it again? Enter in your location's name and select it from the list.
Yeah, and look, the reality is it's probably not that hidden. I've just jumped into screen share. Hopefully people can see that I'm in that extremes tool. I guess for the benefit of others on the call, I had been sort of trying to click in and find the location of a particular place that I was looking for. But by clicking on that magnifying glass over here, it really is as simple as typing in a location without the typos and going in to see what's going on through there, and jumping ahead to sort of see what things are looking like over the next few months. or the time frame that you're looking for. So certainly, you know, I'm no weather guru, but it was fairly simple to try and navigate through that. But certainly that little magnifying glass tool was a fantastic lesson, and I'm sure will help other users. Sorry, I just stopped sharing. Did you want me to share that again?
No, that's good. I was saying that Christine's asked about any details of the Birchip Cropping Group's extension and work that they're doing with their growers. A couple of things. Birchip Cropping Group have a website called Climate Kelpie, which actually has quite a lot of useful blogs. So I've just done a blog there about the move from Access S1 to Access S2, for example. And I think, Kathy, you've done one recently. So that's quite a useful resource. They also, as I mentioned in the presentation, they actually run our monthly community of practice sessions. So if you are interested, maybe I'll give Kathy the details, and you can be put on their mailing list so that you get information about the community of practice sessions. They don't all, so each session is an hour long once a month, and they're usually 2 or 3 presentations. They're not all on Forewarned is Forearmed. They're often on different topics of interest to agriculture. So it's a really nice session.
I'll just share, I've got the Climate Kelpie site. Oh, I'm not sure if that, yeah, it looks like it's going in as a link. It just says the words Climate Kelpie, but it does have the link, and obviously a lot of weather and climate related information on that site. But yeah, certainly they've published some content in recent times relating to Forewarned is Forearmed, and yep, to I think a number of the different agricultural groups who've been involved in that process along the way.
I'll put in information about the Birchip Cropping Group sessions now.
Yeah. Questions from those on the line in your hands about whether you have anything else. In the meantime, Debbie, another one from me. Obviously, with climate change, we are starting, I guess, to experience more frequent extreme weather events. How critical do you see tools such as these that are being developed through Forewarned is Forearmed in helping our agricultural sector?
Very important. So I guess in the past, seasonal forecasts used to be constructed in a statistical way, which is kind of why I sort of started the presentation talking about the fact that these are models that are actually simulating what's going on. In the past, seasonal forecasts used to be created using statistics. And so what that meant is you would look, say, at rainfall over Australia, and you would look at sea surface temperatures in the Pacific, so indicators of El Nino, and you would say, what's the relationship? And then you would apply that relationship going forwards. But so that relationship is devised from looking at, you know, what's gone on in the past. And so it doesn't actually, so what we found is when statistical forecasts started, you know, not taking into account that the climate was changing. And so the one good thing about the dynamical models is that they can forecast conditions that we haven't seen before. They also do take into account to some extent that the climate is changing, because you can prescribe the amount of carbon dioxide and gases in the atmosphere in these models. And they also obviously start, the forecast, as I said, is starting with the current conditions. So it knows how hot the Pacific Ocean is. So they having these forecasts are definitely a step in the right direction to helping with that. And if, you know, in terms of like the northern regions of Australia, the indications are for climate change that, you know, there's an increase in wet season rainfall. So I think, you know, just trying to increase the number of tools in our arsenal to be able to actually, you know, help us, I think is good. You know, there clearly are challenges with forecasts on seasonal timescales. It's not an easy thing to forecast. and you know, it's also hard to understand probabilities and that sort of thing. So so there's a lot of, I think there's a lot of progress we can make in terms of making forecasts more useful.
But certainly any information has to help, right? As the project says, being forewarned is forearmed. You can actually make decisions.
Yep.
Okay, well, look, we're not seeing a whole lot of other questions come through.
I think
so,
there's another one there, Kathy, from Luciano. How does the ensemble size affect the predictions? That's a really good question. So basically, the bigger your ensemble size, the better. And that does saturate. So you probably don't need more than like 100, but there's a big difference between having 100 and only having, say, 5, because basically the larger your ensemble size, the more options you're considering. And it's also, so basically the way that we produce the ensemble takes into account certain amounts of uncertainties that we have. So we have uncertainties in terms of that initial state. When we start the forecast, we don't obviously know what the ocean temperature is in all regions of the ocean, or we don't know at every point in the globe and up into the atmosphere. So we have uncertainties in that initial state, and so we take that into account. And then this is a model, and the model is not perfect, so we have uncertainties associated with the actual model. And so taking that into account is important as well. And that's why it's often useful to, that's why we also look and see what other models are forecasting. So we'll look and see what other international models are forecasting, and see, you know, how much agreement is there between those models. So ensemble size is a very important consideration. Another point about that is that it's very expensive to run these models. We run them on a supercomputer, so we're always trying to balance out, you know, how much can we afford to run on the supercomputer, and so a lot of the stuff is constrained by supercomputer availability.
Thank you. Well, Debbie, we might look to wrap up there. Can I say a big thanks to you for sharing your expertise with us today. We're certainly very grateful for your time and your knowledge, and I do hope that those on the call have found it useful. I can see that Sam has acknowledged a great presentation on a complex issue with a lot of variables to consider, and noting that the tools are very important for all and for the future. So thank you. Look, we would love to hear your feedback more formally too, please, about today's session, and ask if you can please take a few moments to complete the feedback form that I have shared in the chat function. It's a simple online survey. It won't take more than a couple of moments to complete. I've also shared my contact details so that if you have any further questions, please do feel free to reach out, and we'll put you in touch with the appropriate people. We do have another webinar scheduled for this Friday, as Debbie mentioned, and it, I guess, follows on in relation to managing climate variability. Friday's session is from the perspective of users of the tools. So we will hear from Tom Bowditch from the Department of Agriculture and Fisheries. Tom works for Biosecurity Queensland, and also from Robert Quirk, who's a cane grower from northern New South Wales, which has recently particularly been impacted by the extreme rainfall events. So Robert will have some insights from recent experiences as well. We will also have further webinars throughout the year, so please keep an eye out. If you're not already on our distribution list, please reach out. We'll ensure that you're added to that. But thank you, everyone, for attending. We do appreciate your time. We hope you found it valuable, and we look forward to seeing you at one of our future sessions. Thank you.
Thanks very much.
Bye all.